Okay, so let's use Splunk to be able to use machine learning to understand a cybersecurity data set. Okay, so we'll just click here, and then with Splunk we can have a number of experiments and we can try out our model and see if it works. Okay, so we can do smart forecasting, we can look at outliers in our detection, we can cluster, predict, and then we can also predict numeric values. That's where we have maybe an integer value or a floating point value and try to predict it. We can also try to predict categories such as yes and no and true and false, and for string values. We can look at outliers for our numeric values and outliers for our categories. And finally, we can use time-based forecasting or clustering numeric events. So in this case, what we're going to do is we're going to analyze a data set from a firewall on devices which are infected by malware or not. So that's a true or a false. So it's not a numeric value, so we'll pick our categorical fields. We'll create a new experiment and we'll just give it a name, firewall 3. Yeah. Okay, so that's started here. So our data set, so with Splunk we put in our commands here, look up, and the name of the CSV that we have loaded onto the server is called traffic.csv. So we'll just have a quick look to see what that data looks like, and then we'll apply our machine learning model to it once we've understood the data set. Okay, so it's just loading up now, and here it is here. Okay, bytes received, bytes sent, destination port, IP address has a vulnerability, packets received, packets sent, and then at the very end we've got used by malware. Okay, so we've classified all of our data packets as whether a device was infected or not. So this is what we will try to train against and see if we can predict this value based on those fields. Okay, so we've got 98,000, so we'll just reduce that down. We press Shift Enter and we can put bar here, and we'll go for head of 50,000 records, and that should reduce our data set down. Okay, so we now have 50,000 records. We're going to use a logistic regression first to do this, and then what we'll do is we'll select our used by malware to predict the value, and then we'll use all of the other values to be able to train against. Then we select how much we want to split the data for training and then for testing. In this case, we'll go for 70% of the data set to use to train, and then we'll test it against the remaining 30%. Okay, so we now just try to fit the model, and it should just take a few minutes to produce the model. Okay, so now we have the model, so we can see here this is what the value was, and then this is what's been predicted. We can see that some of the time it gets it correct, that's a true positive, but this time here it's a true negative. So sorry, it's a false positive. The value that's predicted is yes, and it isn't infected by malware. Okay, so when we look at the quality, here is the values that we get here, and we want these values to be as near as 1 as we can. When we look at the confusion matrix, then we see that it was right 81% of the time when it wasn't infected, and it was also right 82% of the time when it had malware. But it's still not perfect in any way. So we'll just have a look at the search and see what that looks like. Okay, so that's our syntax there. We'll just tidy this up a little bit, and we'll put it into lines like that. Okay, so that's going to read in the CSV, take 50,000 records, and then do logistic regression for this parameter against all of these parameters, and it's going to call it this model here. If we want, what we can do is that we can actually just copy and paste our table values. So just this is often what we do is we find our script that we need. Here we are here. Okay, so the script that's used to produce the table that we saw on the other screen is actually similar to this script here. So if we want to output this data set to multiple reports, then we use this multi-report, and then we put square brackets in for the first part. So the output of this feeds into that, and then the first part ends here. And then we do the same again for the next part, and we put the square brackets in. Okay, so the output of this will go into here, and it will go into here. Okay, so rather than us repeating it twice, we can do a parallel thing here. So in this case, what we do is we get all our scores here, and this will return a number of scores such as the precision, the recall, and a value of f beta source, which is known as f1. So we just rename that. We round the values to two decimal places, and then that's us finished with here. We'll define a number of fields that we're going to use. And then we'll do the same again here. In this case, we're looking for an accuracy score, which is a different score that we get, and we're rounding it to two decimal places, and that then becomes our output. And we see here we should create, if we run this, we should create our table, which will produce our scoring system. Okay, and there is our table there, as we saw before. The values will vary because each data set will have a different 70% sample. Okay, so if we just go back to where we were, back to our experiment here, so we can click on any of these and we should see the same type of script that we saw before. Okay, so there we go. This is a similar script than what we created earlier. So the next model we'll do is SVN. So this is a model that allows us to create two classifications, and we create a multi-dimensional point and then try to create a gap between the two classifications. Okay, so we'll just go again, and then we've got the same parameters, so we'll try and fit that model. Okay, so this is the model here. So there is a false positive, and if we see the score this time, it's even better than the last time. So now we're up to 0.96. So this is a better model. The SVN is better than the logistic regression model. And we can see here we're getting good scores for our true positives and quite low scores for our false positives. Okay, so now we'll try with, so if we remember that we got 0.96, let's try for random forest linear regression. So this is a fairly general model, which is good in creating complex mappings where we have trees, different decision trees based on probability and so on. So this one hopefully should end up with being the best model for this application. Okay, so that was fairly quick to actually produce that model. It's just going to populate. So it takes Takes a while to run the machine learning model, and then obviously it's then requires to load up the data. You can see it's draft now, so at any time we can save our model, and we can see here this is looking good already. We can see here that we're not actually getting that many incorrect values, and that's the first one there that's incorrect. And now the accuracy is 0.99, which is the best model that we can actually get, well, up to this point. We can see that we're only wrong 1% of the time there, and only 2% of the time. So this is a fairly good model. So we'll just save that, and whenever we go back to our experiment, then it should all be populated for us. So we'll just continue editing, we go back to our experiments, and then whenever you need to find your experiment, it should be here. And we can see here, that's our model there. And then that's it, all created. Okay, so that's been a basic introduction to how to use the machine learning for categorical field prediction.